Hello everyone, my name is Soumya Ranjan Das and in this video I am going to be discussing about merge sort. I'll discuss about the definition of merge sort, how merge sort works, the time complexity and space complexity of merge sort, the advantages and disadvantages of merge sort, its examples and applications. Now let's have an overview of merge sort. Merge sort is a popular sorting algorithm that is used to sort elements in an array or a list. It follows the divide and conquer algorithm, which basically means it divides a bigger problem into smaller sub-problems. It finds the solution of those sub-problems and then merges the solution. Now let's have a look at this example. Here we have 1, 5, 3, 4, 2, 6, which are not arranged properly in a ascending or a descending order. In this algorithm, we'll sort it in a ascending or a descending algorithm. First of all, the array is broken down into two sub-problems. In this case, 1, 5, 3 and 4 to 6 are our sub-problems. Then it's further broken down into two more sub-problems, uh, respectively 1, 5, 3 and 4 and 2, 6. Then 1, 5 and 2, 6, they are broken down into 1, 5, 3, 4, 2, 6. Now after the problem is broken down into sub-problems, the algorithm starts sorting the numbers based on if they are smaller or larger. In this case 1, 5 and 2, 6, they are as it is. If you look at the second last step, we have 1, 3, 5. It was earlier 1, 5, 3. So that means 3 has come before 5, which means that this part of the subproblem that has been sorted. Similarly, for the other side, earlier it was 4, 2 and 6. Now it's 2, 4, 6, which means since 4 is smaller than 6, 4 has come to the left hand side of 6. Then we merge both the subproblems to form the solution of the problem. Moving on to how merge sort works. As I've already told you, merge sort works on the divide and conquer algorithm. In this algorithm, the first step is to divide the problem into sub-problems. The second step is to sort the given problem, and the third step is to merge the solutions together. So first of all, we divide the input array into two halves until the base case of a single element is reached. Then the sub-arrays are sorted recursively using merge sort. And then the sorted subarrays are merged together to form the final sorted array. Now let's talk about the time complexity of merge sort. Merge sort has a time complexity of order of n log n, and that time complexity is the same for its best case, its worst case, and also its average case. This makes it efficient for working on large datasets, on large databases. The divide and conquer approach ensures a balanced workload during the sorting process. Moving on to the space complexity of merge sort. Merge sort has a space complexity of order of n, where n is the size of the input array. In merge sort, we divide an array into temporary subarrays. Now, merge sort requires additional space to store the temporary subarrays during the merging process. The additional space required for the merging process can also be a drawback if you are working for large data sets or for large databases, but we have only limited amount of memory. Let's talk about the stability of merge sort. Merge sort is a stable sorting algorithm, meaning it maintains the relative order of equal elements. This is because in merge sort, the elements are compared in a way that prioritizes the left subarray more than the right subarray. The stability is also useful when sorting objects with multiple attributes or when preserving original order is important. Also, we have to understand that stability is an advantage for merge sort because stability is very important when determining which sorting algorithm to use. Talking about the advantages of merge sort, the two main advantages of merge sort are time complexity and stability of merge sort. For example, the time complexity of merge sort is order of n log n, and that is same for its best case, for its worst case, and also for its average case. That shows why time complexity is one of the biggest advantages of merge sort. The second one is the stability. It is a stable sorting algorithm which is advantageous in certain applications. Certain applications, by that I mean huge data sets, large databases. In those sort of applications, merge sort is very essential and is very helpful in sorting the huge data sets. It is also very useful in sorting linked lists, also because due to its efficient merging process. We talked about the advantages of merge sort. Now we are going to discuss about the disadvantages of merge sort. If a time complexity was the advantage of merge sort, space complexity is definitely the disadvantage of merge sort, because merge sort is a divide and conquer process. It first divides the array into sub-arrays. These temporary sub-arrays require additional space in the memory. Now, for large data sets using a limited amount of memory, these subarrays will require a large amount of memory, and that can be one of the disadvantages of merge sort. The second one is it is not an in-place sorting algorithm, meaning it needs extra money for the sorting process. The third one is the recursive nature of merge sort can lead to stack overflow for extremely large datasets. If in a large dataset we don't have an end to the sorting algorithm, then it could continue to reiterate that same function, which could lead to a stack overflow. Let's compare merge sort with other sorting algorithms. If we compare it with quicksort, in case of smaller datasets, it is slower. If we compare it with quicksort for larger datasets or with linked lists, then it is faster and much efficient. If we now compare it with bubble sort or insertion sort, then merge sort outperforms bubble sort and insertion sort in terms of efficiency. Now the third one is merge sort is a popular choice when stability, efficiency and consistent performance are essential. The real-world application of merge sort. Merge sort is widely used in various applications like sorting large datasets, databases, and external storage devices. This is because merge sort is very essential and very useful in terms of sorting large datasets. It is used in storing elements in parallel computing and distributed systems. Now this shows the efficiency of merge sort and how fast it is at sorting the elements. Merge sort also finds operations in operation based applications algorithms like merge join in database systems. Let's discuss about the performance analysis and trade-offs. As I discussed earlier in the previous slides, the advantages of merge sort are its efficiency and its stability, while its disadvantage is that it takes additional memory for storing the temporary subarrays. Here, in efficiency, merge sort has a consistent time complexity of order of n log n in all cases, making it one of the fastest comparison-based sorting algorithms for large datasets. Now, for stability, merge sort is a stable sorting algorithm ensuring that elements with equal keys retain their original order after sorting. Now, its disadvantage, additional memory. Merge sort requires extra memory space proportional to the size of the input, making it less suitable for memory constrained environments or very large data sets. We now come to the end of the presentation. Thank you for watching.